Hi, welcome back. This is Greg. Installment 2 of our inventory management presentations. This time we're talking about the decisions made in inventory, the types of demand that the different forms of inventory will take on, and those will affect the control mechanisms that we use. So the decisions being made here, the first is when should an order be placed in order to replenish inventory? So really the question is, what's the trigger? What is the reorder point that will say, hey, it's time to buy more? We see this every day in our personal lives, or maybe not every day, but you see it in your personal lives when the light comes on in your dashboard that says, hey, your fuel supply is getting low, it's time to go to the gas station and refuel. So that's a form of a reorder point. Whatever the programmers at the car company said, oh, it should be 1 gallon or 2 gallons or 3 gallons, that's the level at which the light should come on. So the same thing would be for a company. When should they place a new order? What should be the level of inventory that triggers the replenishment process? Second decision then will be, when you decide to order, how many should you order? How much of that item should you order? Regarding gas, perhaps you remember back at being a teenager that when you did have to buy new gas or buy more gas, it would be, well, how much money do I have in my pocket? That's about how much gasoline that you might purchase, whereas today you just perhaps fill it up. So the how many then might be a function of, well, how much of a discount might I get if I do some quantity buying? It might be a function of the holding costs, and it might be a function also really of the ordering and setup costs. So if you only bought 3 gallons of gas every time you went to the gas station, you would find yourself at the gas station quite a bit. So by buying more gas, you reduce the number of trips to the gas station. So you reduce the number of times that you have to purchase gas, really those setup and ordering costs. The third decision might be, so where should you store inventory and what type? So the when and how many, those are the most frequent, the most common questions and that are addressed in regarding inventory. But I think these days, the other two questions I have here are nearly as important. So where should you hold inventory? So where should it be located? How far away from customers? How many distribution centers should you have? And then where should they be located by customers and then around the world? And that's part of the overall supply chain design. We'll talk about that in the next couple of weeks in class. So the fourth question here is not necessarily what type of inventory, but more so what value-added state should the inventory be stored? So should you store it as a complete finished good, or as something a little south of that, maybe more at a component level, so you can still have time to customize that component into a individual end item. As an example, the picture there is of a physio-controlled defibrillator, the LifePak 15. Physio sells LifePak 15s all over the world. So instead of holding inventory of a LifePak for Germany and a LifePak 15 for Japan and a LifePak 15 for Mexico and for Canada and the United States and Brazil, they're just going to hold inventory of almost completely finished LifePak 15s. In fact, they're all finished except for a few things. They need a sticker for the right for the labels. The language has to be appropriate. They need to have the right software downloaded, and then the customization, the features that individual customers want are actually already baked in. All of the features are in the software. They just have to turn on the right switch. So they can take that vanilla unit, they call it, that's almost finished, and then customize it for the individual customer in the individual country. And so they want to store that inventory at that value-added state. All right, so looking around at some of this value-added state and make to stock or make to order, noticing that M&Ms is allowing you to customize, to a little mass customization of your M&Ms. You can choose from, I believe, 24 or 28 different colors, and you can have your own logo or something else printed on those colors. But how many would you buy here? So would I buy 1,000 or 10,000 of these? And if I buy too many, then what do I do with the extra, that obsolescence? Well, I might just sell them on overstock.com. But I probably might get less money for my used M&Ms or my old M&Ms on Overstock. I probably would just eat them, I would say. So when and how much? Those are these relevant, or the questions that we're dealing with. So we need some cost type and cost data to answer these questions. The first cost is this ordering. So if I have to place an order, then I may not, or what are the costs involved in that order? If it's too expensive, I may not want to place very many. So this is the cost of your purchasing people who are executing the PO. There's somebody inside who is making a requisition for that. You have to deal with the invoice that you receive, and you have to pay that invoice. You have to receive the stock. You have to inspect that to make sure that you got what you ordered. You have to perhaps pay for transportation. That's all part of the ordering process. And all part of that, of executing and processing that purchase order. The more expensive that is, probably the fewer times you're going to place an order. Same thing on the inside. If I have to set up machines to make the product that I'm running out of, and I had a trigger for more, then the more time and expense involved in setup, probably the longer the run would be, so I reduce setups. In both of those cases, if you want to do those activities fewer times, that means you're actually going to buy more and then hold more inventory. So there's going to be this trade-off between the cost to get the product, either ordering or setup, and then the holding costs here. And those holding costs might be a function of the cost of the items that we're dealing with. We also have to pay for these products. And then some other holding costs might include the capital costs, the cost of the racks and the storage systems and the insurance and the obsolescence, et cetera, that we talked about in part one. And then shortage costs. So what if we stock out and the customer goes somewhere else? So if we only order 90, but in demand was actually 95, 5 customers came in, they wanted to buy something, perhaps it was an iPad 2 or an iPhone 5 or some other new technology, and we didn't have it, so they end up going to some other store that they may have never shopped at before, or some other channel that they may have never shopped at before, and then they're like, hey, I kind of like this. I'm not going to this physical brick and mortar. I'm going to buy from this other channel. That was great. So the cost of that, you might lose a customer for a long time. That would be very expensive. All the expense around finding and holding on to new customers, to lose them over stock out, that would be unfortunate and expensive. Hard to know exactly what those costs are, but they're certainly greater than zero. So about control, to deal with the control of inventory, we have to first know what sort of demand we're dealing with. And that these types of demand, as you see, they're independent and dependent, are really a function of the type of inventory that we're dealing with. So we're looking at two things here: finished goods inventory or component level inventories, or maybe it's a sort of a raw materials perspective. Let's talk about the independent demand first. So independent is for finished goods. In this case, when iPad 2 was coming out, you see here a shot of a Best Buy employee rolling out a pallet or a cart full of new end items. But these are complete iPad 2. So if you and I walked into that Best Buy to buy one, we'd be taking one of those boxes off the shelf and then taking it home. So they're managing that inventory, but really the demand for the iPad is different, or is independent from demand for anything else that they may have in the store. Conversely, the company that's putting the iPad together, perhaps that's Foxconn, they're managing demand for component items. So they got to manage the demand for some of the things here: the display module, the touch screen assembly, the battery pack, the camera. All those things are components that go into the finished items. So the way we manage the component level inventory is actually going to be different than the way we control and manage inventory for finished goods. Here you see some stuff around the recently released iPhone 5. You see the teardown in the bottom left. You can see the little screws and things. In the first video here we talked about A, B, and C inventory items. Those screws are example of C level items. You wouldn't want to stock out of C items and then not be able to put a whole phone together. So it's likely that Foxconn or other suppliers to Apple are maintaining a large inventory of the screws and the little connector things because they're cheap, and you don't want some inexpensive component preventing you from assembling the quite valuable end item. I circled here the bill of material cost. It says there in that box in the bottom right. The BOM cost, it says. We'll look on the next slide and see what bill of material stands for. That's what the acronym is about. Notice here that manufacturing cost line, $8 to manufacture each of those 3 different forms of the iPhone 5. That's all of the labor that goes into the assembly of the phone for Foxconn and other iPhone 5 suppliers. That's not a whole lot of money. All right, bill of material. So it's basically a recipe. So the A item here, the product, is made up of all of these components that go into it. So you might think of this as a finished dish if you like to cook or bake. That's the final thing, and all the ingredients that might go into that cake. So you might have eggs and flour and butter and other chocolate or other sorts of flavorings that go in. So a component is the stuff that goes in: the amount of flour, the amount of eggs, that will go into that end item. That would be the parent or the cake. Or in the example we were talking about, this could also be the iPad 2 as the parent item, and then you see the teardown of the iPad 2 from iSupply, all those individual components. So the bill of material, the overall recipe, we're going to look at different control mechanisms for independent demand items like finished goods versus dependent demand items. We'll take a look here why some forms aren't so great for dependent demand. So this reorder point methodology that we'll be talking about more isn't great for demand for dependent demand items, and we're going to show you why here. So the red line is the reorder point. The y-axis here isn't labeled, but that's inventory level, and the x-axis would be time. Whenever the line goes down, that's a withdrawal of inventory, and whenever it goes up, it's a receipt of inventory. When the blue line crosses the red line on the way down, that's a trigger. It crossed the reorder point. That means, hey, place an order. Then some time goes by, and then the order comes in, and then we increase the inventory level, and it will go up. So as time goes by, there's going to be a withdrawal then on demand. So what does a withdrawal mean for component levels? Well, that means we're going to assemble a batch. We might be making 1,000 iPad 2s, and we're going to withdraw 1,000 touchscreen subassemblies, or 1,000 of the battery packs, or 1,000 cameras, etc. So it happens all at once. We take out 1,000. So the demand doesn't happen over time. It happens instantaneously. We take that amount out of inventory. Here we have another withdrawal. We have crossed the reorder point. So we're placing an order. That order comes in, right? We receive it again. And a couple of more withdrawals happen. And in this case, the second one takes us into a stock out situation. Let me go back up to that stock out. The stock out occurs here because that withdrawal happens in a large amount instantaneously. It didn't sort of just trickle in over time. Perhaps the company or the inventory manager didn't have visibility into some new order that was going to be required, so they stocked out. Traditionally then, what firms would do is order or hold a lot of inventory of these component parts because they didn't want to have a stock out. The reorder point method just wasn't that great for managing dependent demand items. That means component level inventory. So one of the inventions that occurred over time, and we'll talk about this in a few weeks when we get to planning, is MRP, materials requirements planning. So that's great for component level products that experience dependent demand. We're not going to talk about that anymore in this set of videos. We're going to talk about using reorder point and EOQ methodologies to calculate independent demand solutions. So let's look at independent demand. The example here is the same thing. Red dashed line is the reorder point. The y-axis is the inventory level. The x-axis is time. But in this case, though, you see that the blue line isn't vertical. It has some slope to it. It's angled over time to deal with the fact that the demand happens over time, not instantaneously. So the same thing, though, when the blue line crosses on the way down, that triggers an order. It hit the reorder point. Some time goes by, and we receive. And then again, after the receipt, the inventory level starts to be withdrawn again. One thing about that vertical line on the receipt of the order, the amount of that, the size of that line, how much inventory we received is the Q. We're going to talk about that later on in this presentation, and then when we get to the EOQ information. All right, so the same pattern will occur over time. So we trigger, some time goes by, we receive. We sell more of that product, trigger an order, etc. So you can see this sort of looks like a sawtooth close up. Some people call this model the sawtooth model of demand and reorder point. So in terms of controlling inventory, when are we checking to see if we're out? If you're driving your car, you should be always scanning your gauges and dials to see where things are at, not just waiting for the gas light to come on and say, hey, oh, I didn't expect that to happen. So how often do you look? That's the same thing around inventory as well. So let's look at these decision types or the frequency of them. So there's a range from something we just do one time all the way through to we're looking at the inventory levels constantly, continuously, and then something in between those. So the one-time decisions will be, we call that class of problems, that category, a newsboy problem. So if your job was to figure out how many papers to stock in the machine, that's a one-time thing just for today, how many papers would you put in there? the salvage value of those, if you overstock, if you put too many in or you have too much inventory, then you'll have to get rid of those old papers. Yesterday's newspapers don't have a whole lot of value outside of lining your rabbit cage or something like that. So we'll get to those in class. It's not terribly complicated, but to create basically the solution is, or the approach is, to create a grid of inventory stocking options, how many papers to put in, and then also along the other axis would be, well, what could demand be? So let's say that you could stock 5 newspapers, 10, 15, 20, or 25, and demand could be those same numbers with some probabilities around them. So in each cell, you calculate the value of that cell, the revenue of the cell. If you only had stocked 5 newspapers, but demand was 25, you only sold 5, and you probably had some stock out cost. Other way around, if you stocked 25, but demand was only 5, you sold 5, but you have to salvage 20. So there's a value in each cell, and then you calculate the expected value of each inventory option based on what your probabilities of expected demand. We'll see one of those later on in class. All right, so on the far right then are intermittent decisions. Periodically we would take a look, and those were certainly more in vogue when computers and computer time was more expensive than it is today. That might be something you did periodically. So maybe you checked inventory every Friday or every second Friday or first of the month, something like that. So we're going to focus on the middle here, continuous systems, or what we call perpetual review systems, where if the inventory is being managed by a computer, then all the time the computer's checking on the inventory levels of each of those stock keeping units. And whenever there's a withdrawal, the computer can check right away and say, hey, okay, did that thing trigger that withdrawal? Did it trigger the reorder point? And if so, then we're going to place an order. We'll talk about two-bin here at the end of this coming right up. So that's, again, the perpetual and periodic. You see some more terms around what those things are talking about, but we've already discussed those. So we're going to move on. So what does this look like? Reorder point in a QR system. This is that perpetual approach. So we're going to order Q when we get to R. R is the reorder point, right? That's that red dashed line, and then Q will be the how much. We'll get to those in our subsequent videos around calculating reorder point and calculating order quantity. What does that look like? So perpetual systems, we're always looking at, again, every time a review is made, we check. And then the two-bin system, you place an order when bin 1 is empty, and then bin 2 will cover your lead time. So here's an example, a couple of examples of a two-bin system. If you still use paper checks, or remember them anyway, when you buy a box of checks, that box might have, let's say, 6 books of checks in it. And then after, I think, about the 4th book of checks, at the top of the 5th one will say, hey, it's time to reorder. Use this form to buy more. Underneath that form are a couple of more books of checks, and that's sort of that second bin. There should be enough checks there in order that you can place the order and not run out. That does assume, of course, that you're going to actually execute the reorder when it occurs, rather than put it down in the bottom of the book of checks like sometimes I have been known to do. On the right-hand side, there's a picture of a 1980 or 81, I think, Honda CX500 Custom. I used to have one of those. And those old bikes would have a reserve on the gas tank, and that reserve would serve also as the second bin. So you would go to the reserve tank when your main tank, bin 1, would be empty. All right, that's it on our decisions and demand types. So the next few videos will deal with calculating reorder point, calculating economic order quantity, and then also cash conversion cycle. Thanks.